Okay. Okay, so welcome to our class. Today we are going to solve examination paper of class 12th MP Board Physics. Okay, so we should move towards our first kind of questions. So our first kind of question is choose the correct options. Choose the correct option is first question, number of electrons in 1 coulomb charge are. So number of electrons in 1 coulomb charge are 6.25 into 10 raised to power 80. Correct? Okay. Now second question is in any conductor flow of current is. So in any conductor flow of current is by the free electrons. Now third question is a moving charge produces, this is a repeated question, so we could write it our answer. Answer number 3, static electric field and magnetic field both. For the Lenz law is based on the law of conservation of energy. Okay. Join ho gaye bachche? So question number 5th is speed of electromagnetic waves in vacuum. Speed of electromagnetic waves in vacuum should be C equals to 1 upon mu naught epsilon naught. Now our last question is the overlapping of light in geometrical shadow is called, this is also a repeated question, so we could write it diffraction. Proceed to the next kind of questions, fill in the blanks. So for the fill in the blanks, when current flows through the two parallel current carrying wires in same direction, then they will attract each other. Then they should attract each other. Okay, now the question is transformer work on the principle of electromagnetic induction. Electromagnetic induction, or we could say mutual induction. Electromagnetic induction. Next question is at 0 Kelvin a semiconductor behaves like insulator. So at 0 degree Kelvin a semiconductor should behave like an insulator. Okay, next question is rest mass of photon is considered negligible, so we could write 0. For direct current the inductive reactance is also 0. Now the size of obstacle must be the order of wavelength of light for the phenomena of diffraction. So we could write diffraction on this question. Okay, so our next question types are state true or false. Ionization energy of hydrogen atom is 13.6 electrovolts. So the answer should be true. Next question is when an electron falls from higher energy state to lower energy state, then in this process a photon is emitted. Yes, a photon is emitted. So the answer should be true. Working of hydrogen based bomb is based on nuclear fission. No, it is based on nuclear fusion. So this should be false. Now next question is optical fiber works on the principle of interference. No, it works on the principle of total internal reflection. So the answer will be false. Next is at the condition of normal adjustment the length of tube of astronomical telescope is minus FO minus FE. No, the length should be FO plus FE. So it is also false. Okay, we should move towards the next kind of questions. Next kind of questions are the match the column questions. So for the match the columns, radio waves are given by us Marconi. So our first option will be first Marconi. Second is ultraviolet rays. Ultraviolet rays is given by Ritter. Visible light is firstly shown us to by Newton. Now the question matter waves. Matter waves is given by de Broglie. Equation of photoelectric effect is by the Einstein, and discovery of electron by J.J. Thomson. So these are our options. First is radio waves Marconi, ultraviolet rays Ritter, visible light Newton, matter waves is de Broglie, equation of photoelectric effect Einstein, and discovery of electron J.J. Thomson. Okay, so for the next question, answer in one word. What is the electric potential of Earth? So electric potential of Earth should be 0. Okay, now the question is, what is the value of drift velocity in SI system? Drift velocity is much less than the thermal velocity, so it should be in the order of 10 raised to power minus 4 to 10 raised to power minus 3 meter per second. Okay, so we should move towards the next question. Write the relation between work function and threshold frequency. So for the work function, W naught equals to H nu naught. This is the relation between the work function and threshold frequency. Okay, why the EMF of cell is greater than its terminal voltage? Okay, so EMF of cell is greater than the terminal voltage is due to because the internal resistance of cell. So for the internal resistance of cell, we have to do much work for the EMF rather than the terminal voltage. So its answer should be internal resistance of a cell. Because of the internal resistance of a cell, the EMF of a cell is greater than its terminal voltage. Okay, why the poles of magnet in a galvanometer are cylindrical and concave? So for this, the answer should be to ensure a radial magnetic field. Because of the radial magnetic field, the electric current should always be parallel to the magnetic field, and this will give us the approx value of the electric current in galvanometer. So what should be the answer? To ensure a radial magnetic field. Okay, our next question is straight lines law. This is a repeated question, you could check out in a previous video, so we should skip this question. Now the question is define capacitive reactance, write its SI unit. So for the capacitive reactance, a reactance or we could say resistance offered by a capacitor is called capacitive reactance, or its SI unit will be, SI unit of resistance should be ohm. So its SI unit will be ohm, and the capacitive reactance is the resistance or reactance offered by a capacitor. So this should be our answer. Now here comes our first numerical, a numerical which is saying that a current in a circuit falls from 5 ampere to 0 ampere in 0.1 second. If an average EMF of 200 voltage included, give an estimate of the self inductance of the circuit. Okay, so we are having the value of self inductance. What is self inductance? E equals to L di by dt. So we are having given E equals to 200 voltage, di, we could calculate di, 5 ampere minus 0 ampere, so this should be our di, 5 ampere, dt, we are having the value is 0.1 second. So we should just directly put the values here. So E equals to 200, L is L, di is 5 ampere upon 0.1. If we remove the decimal, it should be 50. So L equals to 200 by 50. 0, 0 cancel out, 524. So we would get the answer 4 Henry. Henry is the unit for the inductance. So this is our question. We just have to calculate the self inductance of the circuit. We have given a EMF of a cell, so it is 200 voltage, di is 5 ampere, time duration is 0.1 second. If we put the value here, so we will get our answer equals to 4 Henry. Okay, now the question is again, it is a numerical, a 60 microfarad capacitor is connected to. So we just let us take the given. So capacitor is 60 microfarad, 60 into 10 raised to power minus 6, connected to a voltage supply, means VRMS equals to 110 voltage, and the AC frequency. So we are having a frequency of 60 hertz. So we are having the value of 60 hertz. What do we need to calculate? We need to determine the RMS value of current in the circuit. Okay, so it is a capacitor. So for the formula of V equals to IR, but it is a capacitance, so V equals to IXC, and we could write it like this: I equals to V upon XC. So we just need to calculate the value of XC. So what is the value of XC? XC equals to 1 upon omega C, and we could write omega as 2 pi F into C. So we are just going to put the value here. I equals to V upon 1 upon 2 pi F into C. So I equals to V into 2 pi F into C. So we are just going to put the values. 110 into 2 into pi into value of F is 60 and capacitance is 60 into 10 raised to power minus 6. So we just need to calculate it, and its answer should be around, if we calculate it, its answer should be around 2.49 ampere. So this should be our answer. Okay, again look at the question. A 60 microfarad capacitor is connected to a 110 volt 60 hertz AC supply. Determine the RMS value of current in the circuit. So we have given capacitance, VRMS and frequency. We just need to calculate the current in the circuit. There is a mistake of the spelling in current. So we just need to calculate the current. So we are having the formula by the Ohm's law, V equals to IR, but here resistance is offered by the capacitor, so we could write it as XC. I equals to V upon XC, but the value of XC is 1 upon omega C and omega is 2 pi F. So our proposed formula should be I equals to V upon 1 upon 2 pi F C. So I equals to V into 2 pi F C. So we just put the value and the solution should be around 2.49 ampere. Okay, now we should move at the next question. Which mirror are used as a rear view mirror in vehicles and why? So for this the answer should be the rear view mirror is used as by in vehicles is convex mirror. And why it is used? Because the convex mirror has a wider field view. Because of the wider field view, we could easily understand our surrounding, and this mirror is useful to us. And there is also a warning is written on the mirror, which is objects are the closer than they appear, because the image of every objects are comparatively smaller than its original size. So that's why we are using a convex mirror, because it could give us a wider field view. Okay, now next question is, half of the bottom part of concave mirror is black. Sorry, this is black. This is black, and what will be the effect of the image? Okay, so this is a question from the 10th class. Concave mirror bottom part should be blacked, and what will be the effect of the image? So here image will form fully, but its sharpness, or we could say its brightness should be low. Its brightness should be low because of the intensity of light. Because of the intensity of light. Because our half part is black-ended, and we could not, if we obey the laws of reflection, so our half part is not going to give any sort of reflection, and the intensity will eventually get low. So our image quality will get disturbed regarding to it, and its brightness should get faded, and brightness should be low, because of the intensity of light. Okay, now next question is, this is some kind of a numerical. Okay, here is given, okay, this is the right part, square root 2. The refractive index of a material is a square root 2. What will be the value of critical angle? So we are having a relation mu equals to 1 upon sine IC. Here sine IC is a critical angle. So we are just going to put the value mu equals to root 2 1 upon sine IC. So we could write it like this, sine IC equals to 1 by root 2. So sine IC equals to 1 by root 2 is the value of sine 45. So on comparing both sides sine, so we would get the value of IC equals to 45 degree. So our critical angle should be 45 degree. There is again another numerical. The magnifying power of an astronomical telescope is 15 and distance between two lenses is 80 centimeter. If both objective and eyepiece are convex lens, then calculate their focal length. So we just need to calculate the focal length of objective lens and focal length of eyepiece lens. Both are question mark. We are having given magnification equals to 15 and the distance separation between them. So we could write it as L equals to 80 centimeter. Okay, so for the astronomical telescope, magnification should be FO upon FE. So if we put the value of magnification is 15 equals to FO upon FE, and we will get the relation FO equals to 15 FE. So we are having a relation between them, FO equals to 15 FE, but the length will be FO plus FE and the value of L is 80 centimeter. For FO we could write 15 FE plus FE. So 80 equals to 16 FE, or we could write FE equals to 80 divided by 16 should be 5. So the value of focal length of eyepiece is 5 centimeter and focal length of objective should be 5 into 15 equals to 75 centimeter. So we have got our values. Focal length of eyepiece should be 5 centimeter and focal length of objective should be 75 centimeters. I am sorry for that. Okay, question number 10. What type of wave front will emerge from? Okay, so from the point source. Point source, a spherical wave front. A spherical wave front will get emerge. So from the point source we will get a spherical wave front, and from the distant light source we will get a plane wave front. So for the point source we will get a spherical wave front, and for the distant light source is we will get a plane wave front. Okay, define the term coherent source. Okay, so coherent source are that kind of source in which their phase will be same. Means there is no phase difference between them, their frequency will be same and their wavelength will be same. So for any two sources could be called coherent when their phase will be same. Phase will be same means there should be no phase difference between them, and their frequency and their wavelength should be same, and they also have to propagate in the same direction. So by the coherent source we will get, there is a call. So for any two sources has to be coherent, their phase will be same, their frequency will be same, and their wavelength should be same, and they have to propagate in the same direction. And if they propagate in the same direction, then we can obtain the pattern of the interference of light. So this is the definition of the term coherent source. Okay, what will happen if electron in an atom be stationary? Okay, so what could happen if an electron in an atom be stationary? So first of all, if the electron is in a stationary phase, so it only produces electric field. But if it is stationary and it is not revolving around the nucleus, then the nucleus will pull the electron. So what will the nucleus do? Nucleus will pull the electron because of the positive nature in charge. So nucleus is positively charged, electron is negatively charged, and if it is not moving, then by the Coulomb's law and by the electrostatic force, nucleus will try to attract the electron and the electron will fall into the nucleus if it is stationary. Okay, next question is, for large angle scattering of a particle, only the nucleus of atom is responsible. Explain the statement. Okay, so for the large angle scattering of particle, so here the particle is considered as a alpha particle, and we already know about alpha particle is a 2 positive particle, or we could say a 2 positive helium atom. So if it strike on electron, so nothing will happen because a positive charge particle is much higher than a negative charge electrons. So it could only be deflected or the scattered by the nucleus because nucleus is positively charged. So only positive can scatter or deflect each other because of its nature. The 2 positive charge will always be going to repel each other. So this is the statement for the large angle scattering of a particle. Only the nucleus of atom is responsible because the electrons are having no say in it, and only the positive particle from the nucleus are going to scatter the alpha particles. Okay, next question is, what is mass defect? Okay, so what is mass defect? Mass defect is generally considered total number of nucleons. Total number of nucleons. So total number of nucleons means the atomic mass, or we could say atomic mass of proton plus neutron should always be more than the mass of nucleus itself. So we could say the mass defect equals to mass of total number of nucleons minus mass of nucleus. So this is considered as the mass defect, and because of the nuclear binding energy, there is a little bit of a difference of the mass of a nucleus corresponding to the number of nucleons around it, because when they combine itself by the nuclear binding energy, so they just emit, or we could say they could emit their nuclear energy as a form of a binding energy, but I don't think so that will happen. But this is a phenomena because of the mass of total number of nucleons minus mass of nucleus should be considered mass defect of any atom. Okay, now we should move towards our next question. Define radioactivity. So what is radioactivity? Radioactivity is the disintegration of any nucleus by a spontaneous emission of a radioactive particles like gamma rays, X-rays and alpha particles. So this should be called as the radioactivity terms. What we could say, the spontaneous disintegration of the nucleus of a heavy atom. So its nucleus will spontaneously get disintegrated, and the activity which they get doing will known as the radioactivity, and it releases the particle like alpha particle and the gamma rays and all. Okay, so this is known as the radioactivity. Now comes the question, define internal resistance of a cell, on what factor it depends and how. Okay, so first thing is the internal resistance of a cell. So for the cell, the resistance is offered by generally by the electrolytes and the electrodes. So the resistance offered by, we could say, resistance offered by electrolytes or electrodes. Okay, next thing is what factors it depend and how. Okay, so first thing is the distance of electrodes. If the distance of electrodes is larger, so its resistance will also be more. So if we increase the distance between the electrodes, then the resistance will also get increased. Second thing is the temperature. Okay, for this, if we increase the temperature of any electrolytes or any cell, its ions will get kinetically charged. So it will get a kinetic energy related to it. So if we increase the temperature, then the resistance will decrease. So resistance is inversely proportional. Resistance will decrease. So resistance is inversely proportional to the increase in temperature in a cell, but it is directly proportional for the metal or the conductors. So here the temperature can increase the conductivity and it will decrease its resistance. Okay. Now question number 13, define resistivity. Resistivity of a substance. Okay, so resistivity of a substance is an intrinsic property. Resistivity of a substance is an intrinsic property, and this is a fundamental property which offers us resistance, or we could say it is the inversely proportional to the conductivity. Now comes how the resistivity of a good conductor and semiconductor vary with temperature. So for the good conductor, if we increase the temperature, resistivity will increase. Resistivity will increase. And for semiconductors, resistivity will decrease. So here we are going to again look at the resistivity of substance. Resistivity of a substance is intrinsic property, or we could say a fundamental property of any substance that offers us the resistance of a particle, and it will depends on the particle basis. If it is a good conductor, its resistivity should be low, and if it is a bad conductor of electricity, then its resistivity should be high. Now comes how the resistivity depends on the good conductor. So for the good conductor, resistivity will increase with the increase of temperature, and for the semiconductor, resistivity will decrease on the increase of its temperature. Okay, question number 14. By-Savart law and write in its vector form. Okay, so what is By-Savart law? Generally, the By-Savart law means the magnetic field is directly proportional to the electric current. Second thing is magnetic field is directly proportional to the component area, component length. Second, next thing is it is directly proportional to the angle between a point, means radially angle. So we could say it directly proportional to the sin theta, and the magnetic field is inversely proportional to the distance of separation of the point. So we could write it like this: dB directly proportional to IDL sin theta upon r square. So we could write dv equals to, when we remove the proportional we will get a constant. Here constant is mu naught upon 4 pi I dl sin theta upon r square. But if we need to write it in vector forms, so we could write it like this: mu naught upon 4 pi I dl into r vector upon r cube. This should be our vector form and its unit should be Tesla. So for the Biot-Savart law, it is directly proportional to the intensity of electric current, it is directly proportional to the length of the component, it is directly proportional to the angle between them, it is inversely proportional to the square of the distance separation between them. When we combine them, it would be look like this: dv directly proportional to the ideal sin theta of the r square, and db equals to mu naught upon 4 pi ideal sin theta upon r square, and this is its vector form. db vector equals to mu naught 4 pi idl cross vector r vector upon r cube n cap, and its SI unit should be Tesla. Okay, question number 14th, or state and prove Ampere circuital law. So in previous question we have already stated the Ampere circuital law. Now we are just going to prove the Ampere circuital law. So for any current carrying loop, the magnetic field should be B equals to mu naught I upon 2 pi r. For any current carrying circular loop, the magnetic field should be mu naught I upon 2 pi r. So according to the Ampere circuital law, the line integral of B into dl. So for a circular loop, if we integrate dl, we will get its perimeter, and its perimeter should be 2 pi r. So if we put the value of B into dl here, so B should be mu naught I upon 2 pi r into 2 pi r. So 2 pi r will get cancelled out. So we will get our statement B into dl equals to mu naught I. This is Ampere circuital law. So this is the Ampere circuital law for a current carrying circular loop. Okay, question number 15. Question number 15 is write the difference between N-type and P-type semiconductor. This was already done in our previous video. In our previous video, we have did a mistake related to the N-type and P-type semiconductors doping. So for this, the doping, we have written the false doping. So for N-type, we could relate to its pentavalent, and for P-type, the doping should be trivalent. So this is the difference between the doping. In our previous video, we have did this wrong, so we just corrected it. So for the N-type, we are going to add pentavalent kind of particles, and for P-types, trivalent types of particles. Okay, so in our previous video, you could also see the answer related to it. Okay, this is our next question. Write difference between intrinsic semiconductor and extrinsic semiconductor. Okay, so for this difference between intrinsic and extrinsic semiconductor should be, first thing is doping. Doping. So for intrinsic semiconductor, generally they are the pure semiconductors. So there should be no doping. Equal number of holes, equal number of electrons. And for the extrinsic semiconductor, they are get doped. They are get doped by pentavalent or trivalent compound. So doping in the intrinsic, they are pure, and for the extrinsic, they are getting doped by the pentavalent or trivalent kind of compounds. Okay, second thing is their charge carriers. So for their charge carriers, we are going to talk about intrinsic. Intrinsic, equal number of holes and electrons. Okay, and for the extrinsic, there are two types of extrinsic conductor. in n types, majority electron, and for the p type, majority holes. So for the charge carriers, intrinsic has equal number of holes and electrons, and for the extrinsic, n type electrons and p types hole. Okay, now we should move towards the conductivity. Okay, so for the conductivity, intrinsic. Generally, intrinsic consist of low conductivity of electricity, and it is highly dependent on the temperature. If we increase the temperature, then we are having the greater number of holes, greater pair of holes and electrons, then its conductivity will increase, but generally they are of low conductivity and majority dependent on the increase of the temperature. But extrinsic semiconductor, they are generally good conductors. They are generally good conductor because of the abnormalities of the electron hole pair, and we are getting the additional charge related to it, and they are less dependent on the temperature regarding to the intrinsic semiconductor. So they are highly dependent on the temperature, but the extrinsic semiconductors, they are low dependent on the temperature related to our intrinsic semiconductors. So these should be our three differences, key differences. Okay, now explain the working of a PN junction diode as a full wave rectifier. This was done in a previous video. Sorry. This was done in a previous video. You could check it out. Okay, we should move towards the next question. Okay, both questions are done in a previous video. This question is also done in our previous video, and this question is also done in our previous video. So the question number 16, explain the working of PN junction diode as a full wave rectifier with circuit diagram, is done in our previous video. And the or option is also explain the working of PN junction diode in forward bias and reverse bias with circuit diagram, is also done in our previous video. So we should skip this question and move towards our next question. Okay, our next question is state and prove Gauss theorem for electric field. Okay, so what is the Gauss theorem? Gauss theorem is generally, we could consider our total net electric flux related to a closed surface is always 1 by epsilon times to the charge present inside in it. Okay, so we just need to prove this statement, phi equals to q by epsilon naught, or we could write it like this, phi equals to d phi equals to EDS. Okay, so for this we are going to prove. So for phi we could write E into ds. We are going to prove our Gauss theorem. So we are just going to solve it. D phi, we are going to put the value of electric field. Electric field value is 1 upon 4 pi epsilon naught q by r square into ds. Okay, so this is the value of our electric field. We could write it like this, 1 upon 4 pi epsilon naught q into r by r cube into ds. Okay, just look at this thing, r by r cube into ds. If we totally integrate it, d phi, if we integrate it, so we will get a solid angle. This is referred as the solid angle, and its value should always be 4 pi. Okay, so if we are going to integrate it, so we will get the value of d phi will be phi equals to 1 upon 4 pi epsilon naught into q integration of r by r cube cos theta into ds. So this angle should be q by 4 pi epsilon naught into 4 pi. This is our solid angle. So we will get 4 pi get cancel out. So we will get our statement phi equals to q by epsilon naught. This is the statement of the Gauss theorem. The total electric flux related to a closed surface is always 1 by epsilon times to the charge present inside in it. Okay. Our next question is, deduce a formula for the capacitance of a parallel plate capacitor. What are the factors affecting the capacitance of capacitor? Okay, so first we are going to draw parallel plate capacitor. They are connected to a positive charge plus Q. So here charge will go like this. These are our parallel plate capacitance. Okay, and it's the other end of the second plate is going to get earth. Okay, so for the parallel plate capacitance, we already know the electric field is always be sigma by epsilon naught. But by the relation of the electric field and the potential, we already get the E equals to V by, and the distance separation between them is D. So V by D. So we will get V equals to ED. Put the value of E in the from the above equation. So we will get V equals to sigma by epsilon naught into D. But sigma equals to Q by A. So we could put V equals to Q into D epsilon naught A. Okay. Now we just know the value of the capacitance. So capacitance equals to Q equals to CV. So C equals to Q by V. Q, put the value of V from here to here, QD into epsilon naught A. So Q will get cancelled out, so we will get the value of C epsilon naught A by D. Okay, now we are going to talk about the factors affecting the capacitance of capacitor. So first one is the medium which is going to filled in the parallel plate capacitance. Second is the area of the plates. Second is the area of the plates, and the last one, it is the inversely proportional to the distance separation between them. So these are the three factors that are going to affect the parallel plate capacitance: the medium between them, median between the plates, and the area of plates, and the last one is the distance separation between the plates. Okay. Now question number 18. Write Kirchhoff's law of electric network and explain with draw circuit diagram. Okay, so first law of Kirchhoff. First law of Kirchhoff is generally based on the conservation of charge. Suppose there is a junction. This is our junction O, and here some charges are coming. Suppose I1 and I2 is coming and I3 is leaving. So for the algebraic sum of the electric current will always be 0. So we could consider the charge coming to the point O is positive, and consider the charge leaving from the point O is negative. So I1 plus I2 negative I3 should always be 0. So we will get I1 plus I2 equals to I3. So this is our first law. So what is our first law? The algebraic sum of the electric current should always be 0. Okay, so we should talk about our second law. So for the second law of Kirchhoff's, second law is also known as a mesh loop or a closed loop kind of. Suppose there are two cells which are going to connect. This is our resistance R1, this is our resistance R2. Okay, they are connected to an external resistance R3. Okay, so generally this is our E1, this is our E2. We will get I1 here and the charge I2 here. So at this point we will get the current I1 plus we will get the current I1 plus I2. Oh, sorry, I am connecting two cells here and that's my mistake. This is E2 and this is I2. So we will get current like this. So the algebraic sum of total voltage, or we could say the potential or EMF, is always equal to the algebraic sum of the current and the resistance present inside in it. So we could write it like this: sigma epsilon sigma E means total EMF should always be equals to the sigma IR, the resistance provided in it, or we could write it like this, sigma E minus sigma IR equals to 0. So this is our Kirchhoff's second law. We could also say it as the closed mesh loop. Okay, we should proceed to our next question. And why did I rub it? I have no idea. Okay, our next question is, what is a Wheatstone bridge? Established principle of a Wheatstone bridge. Okay, so Wheatstone bridge is generally are combinations of four resistance in a quadratic manner. In a equilibrium position, in a galvanometer we got no current. So this is a galvanometer, this is a key K2, this is connected to a cell, and there is a key K1. Okay, so when we press a key 1, the current inside in it get flow of the closed circuit, and here it gets I1, it's get I2, it will be I3, and it should be I4. Okay, and we could term the resistance P, Q, R and S. And the principle of the Wheatstone bridge is the resistance of the adjacent, means the adjacent resistance ratio should always be equal to the ratio of the other adjacent resistance. So we could write it like this, P upon Q equals to R upon S. We just need to prove this principle, or we could say we need to establish the principle of Wheatstone bridge is P upon Q equals to R upon S. Okay, so we are going to prove it. So according to the Kirchhoff's first law, at point B, so there is the current I1 is coming, and the current is leaving is I2 plus Ig. Ig is the current which are going to the galvanometer. So in ideal condition, the current in Ig equals to 0. So we will get I1 equals to I2. Okay, so this relation I am going to write here because we need this relation again. Okay, so at point B, we already got our relation I1 equals to I2. Now for similarly at point D, we will get the current is coming I3 plus Ig equals to I4. So if at the equilibrium condition Ig equals to 0, so we will get I3 equals to I4. So we have already also got another relation I3 equals to I4, which we are going to write again at the top end. Okay, now by the Kirchhoff's second rule, look at the closed loop ABDA. Closed loop ABDA. So we are going to consider our resistance I1P plus IgG equals to I3R. In the condition of equilibrium, this value will get 0. So we will get I1P equals to I3R. This should be our first equation. So we could write here I1P equals to I3R. Okay, now in the closed loop BCDB, or we could write it as CBDC or BCDB. So for this, the BCDB, for this the coming resistance and the current is I2, sorry, the going one is I2Q equals to I4S plus IgG. But in the condition of equilibrium, so we will get I2Q equals to I4S. This should be our equation 4 and 3rd. So if we are going to divide equation 3 by the equation 4, we will get I1P equals to upon I2Q equals to I3R upon I4S. But from the above way, we already know I1 equals to I2, so they will get cancelled out, and I3 equals to I4. So we will eventually get our relation, which is P upon Q equals to R upon S. This is the principle of the Wheatstone bridge. Okay, we should move towards our next question. Our next question is explain alternate current dynamo under the basis of following question. This is a repeated question, so we are going to skip it. Okay, next question is derive an expression for the mutual inductance of two long coaxial solenoids of the same length bound over each other. This is also a repeated question, so we are also going to skip it. Okay, now comes the next question. These are last questions. Describe compound microscope on following heads, so ray diagram of formation of image. Okay, this is also a repeated question. You could check out our previous video for the solution of those questions. Okay, so the last question of the day should be, for any prism, prove that mu equals to sine A plus delta m by 2 upon sine A by 2. Okay, so we are going to solve this question. Okay, so for this we are just going to need a prism, and we are going to make a circuit array diagram related to it. So this is our incident ray, and we could draw a normal around here. It get refracted along with it, so this will be our angle of incidence. We could write it as I1, and this will be our refracted angle R1. Okay, here is also normal is going to propound it, and this angle should be R2, and the ray will get move away from the normal, so this should be our I2. If we, this should be our angle of deviation. If we combine our whole lines, we will get the angle of deviation. So we could give them P, Q, R, S, or we could give name of our prism A, B, C. This should be our point N, and this should be our point M. Okay, for just look at the angle of deviation delta. So in triangle MQR, our angle delta should also equal to those angles, and those angle will equal to the I1 minus R1 plus I2 minus R2, or we could write it like this: I1 plus I2, this is a 1, minus R1 plus R2. Okay, so for the condition of the minimum deviation, we could write I1 equals to I2 and R1 equals to R2 for the condition of minimum deviation. So we could write delta m equals to 2I minus 2R. Okay, now we just need to find the remaining values. Okay, so now comes in the triangle QNR. Triangle QNR. The angle QNR equals to 180 minus R1 plus R2. We could write it as like this. So we will get the value of angle QNR. Now comes to the quadrilateral AQNR. So for the quadrilateral AQNR, this is our quadrilateral AQNR. The total sum of angles of a quadrilateral should be 360. So we are going to add our angles. So our first angle is angle A plus angle AQN plus angle QNR plus angle NRA equals to 360 degree. We are just going to put the value angle A plus angle AQN is a normal, so it should be 90 degree. QNR is the value 180 minus R1 plus R2. NRA is also a normal, so it should be 90. Okay, this is a 360. 90, 80, 90, 360. So we have the value A minus R1 plus R2 equals to 0, or we could write A equals to R1 plus R2. But for the minimum deviation, A equals to 2R, or we could write r equals to a by 2. Okay, so we are having the value of r equals to a by 2, so we are just going to put this value here. So delta m equals to 2i minus a, or we could write I equals to delta m plus a by 2. So this is our value of I and this is our value of a. So by the Snell's law, we would get mu equals to sine I upon sine r. For the minimum deviation, so we will get mu equals to sine, value of I is delta m plus a by 2 and the value of r is a by 2. So this is the expression we need to prove and this is done. Okay, so we have solved our paper and by this we are just going to end our stream. Hope your doubts will get resolved by it. Okay, we will see you again in our next video. Thank you everyone.